Okay, guys, let's look at this problem here for our review. So this is one that we had trouble with. It's a comparison problem. So we're looking at the combustion of ethylene proceeds by this reaction. So we've got our ethylene and oxygen combining to form carbon dioxide and water. So two things. First, we want to know if the rate of disappearance of O2 is 0.28 molar per second. We're going to calculate the rate of appearance of CO2. So I see two things. So I need to make a comparison using the stoichiometric coefficients. So since O2 is a reactant, it's disappearing. So that's our negative 1/3 of the change in concentration of oxygen over the change in time. And then carbon dioxide is a product. So that's 1/2, because of our coefficient of 2, change in concentration of CO2 over time. So now what I'm looking for is the CO2. This whole piece here is the rate of CO2. So I need to get it by itself. So to do that, I'm going to multiply by 2. So what I end up with is that the rate of CO2 is equal to 2/3 the rate of oxygen. And I'm given that oxygen rate. So I'm just going to take 2/3 of 0.28, and that gives me 0.187 molar per second. I'm going to do the same process, but this time I know the rate of disappearance of O2, and I want to calculate the rate of disappearance of the C2H4. So I'm going to do the same thing. I'm going to set up my comparison between the two values. So I'm using my stoichiometric coefficients. So it's 1/3 of the change in concentration of O2 over time is equal to the change in concentration of C2H4 over time. Our stoichiometric coefficient is 1, so we don't include that. So this piece here is what I'm looking for, so it's already rearranged. So I know that 1/3 the rate of O2 is equal to the rate of C2H4, which is going to be 1/3 of 0.23. So our answer is going to be 0.0767 molar per second.